Hi, thank you for coming to the Yahoo Hive talk, the talk that stands defiantly between you and your lunch. I don't know why I'm pointing. So today you will hear testimony from a Hive user from Yahoo who set up a mobile analytics data mart using Hive, among other things. My name is Mithun. I incidentally teach karate at the Columbia Neighborhood Center in Sunnyvale, California. I am known on occasion to sneak into Yahoo and check in code for Hive. I'm a Hive committer, and this is the third time I've had the pleasure of presenting at the Hadoop Summit. So if any of you have heard me speak before and are back for more, I salute your appetite for self-punishment. Let's move on. A quick recap. So at the Hadoop Summit last year, I presented some of the unique challenges that are posed by the large metadata that we have at Yahoo to the Hive Metastore. Metastore is the one on the right. So I showcased an email sent from one concerned user, he's in the audience today, that the concern was around the fact that they were producing about several terabytes of data every hour for this data set, several thousand partitions. And they were using 6 levels of partition keys, and for some reason, their queries were not getting off the ground. Now, since then, we have resolved those issues. I'm happy to announce that a key member of that team is present here today to present his use case. So, ladies and gentlemen, this is Joshua Walters.
Hello, I'm Josh. I'm a software engineer at Yahoo. I build data pipelines. I've worked on the largest audience data pipeline inside Yahoo. We process about 200 billion events a day. This comes out to be several hundred terabytes of data. We also work with a lot of users who are accessing this data and building data marts. A little bit about one more other thing. Oh yeah, a few weeks ago, my crowning achievement at Yahoo, I ate an entire plate of deep-fried cookie dough. Definitely going to go down as probably one of the most prominent things I've accomplished at Yahoo. If you want to stalk me, there's my website and my Twitter. So we have lots of data users, and they come to us with a lot of questions. The main 3 things that they ask us are how can they make their ETL run faster, how can they make their queries run faster, and how can they get people to ramp up, onboard, or be able to use this data faster. So we're going to look at a sample use case here. There was a mobile analytics data mart that we needed to build a pipeline for. They were going to be looking at things like swipes, clicks, installs, standard mobile analytics type traffic, and see ramp up and user acquisition. They really wanted to focus on performance. How fast can they get these queries in this ETL to run? It would be really useful to be able to iterate and run a whole bunch of experiments very quickly. So we looked at our tech stack, and we used almost exclusively Hive, Pig, Uzi, kind of traditional Hadoop tech stack there, and we wanted to make it faster for their use case. So we started going through what are the easiest things we can do to speed things up. So of course, there's some settings, the low-hanging fruit. It doesn't take a lot of work to get this stuff going. So Tez is a huge, huge win. Every single job inside Yahoo that runs a Hive or Pig job is going to run on Tez. By default, you can't even run in MapReduce mode anymore, I think. So that's a very, very large performance gain for a very small, at least from our end, a very small change. For the grid team, they had to do quite a bit of work. There were a few other settings that ended up being pretty useful. Vectorized query execution, it depends on the Hive version you have installed. It may or may not be enabled. Basically, it pulls out batches of data and runs them in tight loops, which gives better JIT compilation, so it runs a lot faster. Pretty easy to turn on. Big performance gain right there. 2 other settings, map side aggregates and auto convert map join will basically shift a lot of logic from the reducer side to the map side. You don't have to do a whole lot for it, and you can get some nice gains right there as well. But this is not enough for our users. They still need it to be a little bit faster for their ETL. So we started looking at data partitioning. We love partitioning data, as Mithun mentioned previously. Data partitioning is where you kind of split the data on a column so that way you have similar data grouped together, so that way queries can only access relevant data and not read other data. Now, deep data partitioning is where you have nested partitions of partitions of partitions, and it goes on and on as far as you want. The problem is it can't go as far as we would like. There are some problems with hcatalog when you start getting into thousands or tens of thousands of partitions an hour. Mithin's going to talk more about this in a little bit. There's also other scale issues. If you do this naively, you'll have reducers blowing out your namespace by generating way too many part files, because each reducer can write to every single partition. Reducers might have too many open file handlers and just crash. Luckily, we do have a few solutions. We gave a talk at Stanford's extremely large database conference last year, where we talked about our methods, where we use a kind of a simple statistical sampling job before we do the deep partitioning. You can watch the video, or you can read the abstract. As a side note, when you do deep partitioning, if you use an advanced compression system, it really gets a huge boost out of it. Because when you have these multiple nested partition levels, you end up grouping very similar data together. So it gets more and more similar the further you go down this partitioning scheme. Because of that, we're able to get much, much higher compression. We'll go over that in just a second. So another thing we tried that didn't really pan out was using solid-state drives to run our Hive cluster. Largely because we were CPU-bound and not disk-bound, it didn't really give us a huge boost there. We wanted to try a few other things, maybe using it for transient data in between the map jobs and the reduce jobs and kind of store some stuff there, but we didn't mess around too much with that. It's something we can try later. So in general, we've concluded that for these sort of setups, a traditional spindle drive is fine. So now we get to our file format. So we use orc for every single output of every single data system inside Yahoo now. We really like orc. It works very well for our use case. We get incredibly high compression rates when compared to plain text, roughly 30x. It depends on the partition and the data set, but very, very significant compression gains there. It also has really good query performance. Orc is a very nice format in that it compresses things in these like stripe blocks with these headers. And the header has useful information that can let you know if you need to compress or decompress the block if your data may or may not be inside that block. There are things like Bloom filters that you can add that get kind of interesting. And a really useful one for us is if you have a sorted column and you query that sorted column in orc, it's able to use this min-max stripe header information to really boost your queries about 90%. So that's a significant gain. So at this point, we have pretty fast ETL. But we haven't answered the other two questions. How can we get queries to run a lot faster? So sketches is something that we're using very, very heavily now. So sketching algorithms, they're kind of a family of probabilistic data structures or probabilistic algorithms. There's a library out of Yahoo called Sketches. And what this does is it enables you to do distinct value count estimation. So you can count the number of elements in a set as an estimate. This is very, very, very fast. It runs in a single MapReduce pass. You don't have to do any weird shuffling or sorting to get this done. It's incredibly accurate. You can control the accuracy of your sketches. You can also do things like standard set operations, union, intersection, set difference. So you can actually use these small binary objects to do advanced queries. Now, the sketch sizes for, I think, a few kilobytes, like 4 or 5 kilobytes, you can do a distinctive value count of hundreds of billions of elements, which is really, really nice when you roll these up over days. So as you see, about a 75% boost on relevant queries, and here's a sample query right here. We have at the top a very simple Hive query that just does a count distinct on some column. These are very, very, very common type queries. And with sketches rewritten using the Hive UDFs, very straightforward, you get a 75% speed boost for almost no loss of information. I think it's a fraction of a 0.1% loss in accuracy there. So a little bit about accuracy. This chart is really complicated, but at a high level, the larger your sketch size, the more accurate your estimate. So this is measuring the standard deviation confidence intervals, but the takeaway should be as you increase k, which is the size of your sketch, you increase the accuracy of the output of your sketch. So once you get around 4,000, 16,000, you're probably good for your use case. So we also have, there was a talk given about sketches last year at Hadoop Summit, and there's also the code. It's open sourced. It comes with Hive UDFs, Pig UDFs, and the Java code, so you can find it all there. We also have users doing a lot of these advanced queries. Common ones that we see are funnel analysis, some people doing things with like graph, trying to see graph chaining. They'll do things like dump it to a different database or write incredibly complex Hive queries. Now, we talked a lot with these users about how we could enable them to do these sort of queries faster, and one of the conclusions we came to was that a lot of this could actually be done with well-done UDFs. You can actually solve a lot of these problems with UDFs, and I'm going to go over a sample use case here, funnels specifically. So funnels are a way of tracking conversion rates of users through a series of steps. So the standard example is someone goes to your site, clicks sign up, inputs their information, and then clicks submit. So that's a 3-stage funnel, and what you want to do is see the fallout of users at each step. If you want to write this in Hive, this becomes a very tricky query. You have a whole lot of joins, you have sequential selects. It can become very, very complicated, and we have users that were writing some of these funnel queries with up to 20 steps. So when you start getting up to a 20-step funnel, these queries were taking 6 to 8 hours, which is completely unusable at that point. So what we did was we wrote a custom UDF to solve this problem because it was so common for our users, and it's able to do it in a single MapReduce pass. It's able to take a 6 to 8 hour query and finish it in seconds or minutes, depending on the size. The code's open source, so feel free to check it out. But this isn't really to hype this, but more to say, for some of these complex use cases, if you take a step back and think about how you could write a UDF for this, it often can be done and a lot easier. So another really common use case that we saw was kind of these BI OLAP style queries, usually from marketing or sales, where they want to check trends over time. It's usually involving a group by some sort of sum, a count. If you can render it as a graph, this is a good use case for this. And our question to ourselves was, could we enable these queries to run faster? Because they're useful if you can kind of dig into them, tweak a few parameters, see how the graph comes out. Luckily, there is a great system to do this called Druid. It's open source, it's actively maintained. We use it very heavily inside Yahoo right now. What it does is ingest raw records. So your raw records flow in from your Hadoop Hive store. It then aggregates it itself. So it will do all its own rollups. It will not store raw data. It uses some sketchy stuff actually in the back end as well. Then from there, you can query it and get you can just get aggregate results very, very quickly. I'm talking sub-second, often very, very small millisecond latency to do these queries. So you can build these graphs and charts and just kind of interactively change them. So at this point, we have faster ETL, we have faster queries, and now we want people to be able to onboard faster and actually access and use the data. So what this means is a BI tool. Now, there are many, many different BI tools out there. There are lots of options, but the problem is they don't cater to our needs exactly. They don't have support for Druid, or they have support for Druid, but they don't have support for Hive, or they don't have support for MySQL or Postgres or some other system that people are using. So we looked high and low to find a system that could meet some of these needs. We ended up settling on Caravelle. It actually works really, really well for us. It's an open source BI tool that's very new. It's out of Airbnb. We're actively contributing back to it, and they're very actively contributing to it. It enables very simple query construction. It's very nice for building dashboards, graphs, pie charts, things like that. I recommend checking it out. A lot of people are using it. It's been gaining a lot of popularity the last 4 or 5 months. So this is now our recommended BI tool for ramping up users. So at this point, we helped the team build an efficient data mart. And we were trying to see what we learned from this whole process. What can we take away? Product teams need these data marts. They need to take from the data warehouse, do their own transformations, and store it in a way that's useful to them. The problem is these data marts are really complicated to build and run. You have to know a whole lot of Uzi, you have to know Pig, Hive, you have to do a whole bunch of Bash and Python scripting, and then debugging the whole thing can take you a while. We really just want our users to be able to focus on their core business logic, what it is that they need to do with the data, and not worry too much about this backend stuff. Which is why we built a generalized architecture to enable customers to build data marts quickly. The idea being you write an ETL query, an ETL Hive query to extract out the data that you need, And then boom, you have a data mart up and running in a matter of minutes. The simpler to use, the better. So we focused a lot on best practices, things like automatic continuous delivery. So right out the bat, once you provide that query, you have a full CI/CD pipeline. You have all your different jobs set up. We'll go over the architecture in just a second. And so we've used this very successfully. We have about 20 to 25 teams using this now inside Yahoo. So here's the high-level architecture. This is going to be for our data set. So we produce hourly data. For you, it might be a little bit different. But at the very bottom, you see event data flowing in. You have our hourly ETL, which processes the data and then dumps it to Hadoop. You then have the daily rollup, which processes 24 instances of the hourly data and dumps it to Hadoop. And then at the very end, you have an optional aggregate if you want to do rolling windowed aggregates. This was a common use case for some of our users. So that consumes the last X days of data and then dumps that out. Once that's all in Hadoop, Druid then takes over, pulls out the relevant data, aggregates it, and then stores it. On top of that, you have your BI layer. In our case, it's Caravel, which is able to execute queries on Druid and Hive. So we didn't do all of this alone. A lot of these problems we had with some grid technologies were very, very difficult, and they were not solved by us. They were solved by Mithun and his team, and he's going to go over some of the issues that they faced when helping us with this. So here's Mithun.
A note on why Hive, the version of Hive that we're running at Yahoo. So currently we're running Hive 1.2 against Thales 7. One of the reasons we're running Hive on Thales at Yahoo, one of the goals that we have is to be able to run sort of your larger queries, for example, ETL-ish sort of batched queries that take a very long time to run, and the shorter sort of more interactive queries, preferably on the same hardware, using the same infrastructure, using the same software. We don't at Yahoo afford ourselves the extravagance of standing up tiny, siloed, underutilized clusters that are dedicated purely to interactive queries. Multi-tenant clusters, which are kept busy often, is the key at Yahoo. So what we would prefer to do is, at the top you can see a cluster that's 4,000 nodes, very, very busy. We define a 3% queue off of that cluster, which is then used for interactive queries. So we turn our users to use that queue. As you can see, that's pretty busy as well. Now, we know that HDFS bandwidth, network bandwidth, disk bandwidth, and so on are not isolated to a queue. So it is shared resources. So where do you get performance? You would have to tune the crap out of it. So as a result of this tuning, at least in this use case, the users got pretty good performance. 50% of their queries completed in under 30 seconds, 75% in under 4 minutes. Now, tuning Hive can be daunting. There's a lot of knobs and switches and turny things. In fact, if you look at the number of lines of code in hiveconf.java, as versions of Hive progress, you kind of see that there is a marked increase over time. A friend of mine in Hortonworks likes to joke that Hive Jira is not complete unless it introduces 2 new config variables at minimum. That would be funny if it weren't also true. So let's look at some tuning parameters. Out of the box, you really should be enabling Thales container reuse to amortize the cost of container spin-up. You want to enable speculative execution to get around your slow nodes or your slow tasks. On occasion, we've gotten 2x performance just from there. There's also vectorization. Now, Hive 1.2 has reduced side vectorization that is both performant and stable. So we have turned those on in production as well. Second, it's good to understand your data and data format. Now, Josh has already spoken about how in ORC, the ORC reader can examine your selection predicates and skip records or sets of records based on min-max values that are stored in line. Now, that gives you tremendous performance boost. If you'd like to take advantage of this, perhaps sorting on the columns that you most often use in your predicates is a good idea because they'll be contiguous and easier to skip. 1.2 introduced Bloom filters with a configurable false positive percentage that allows you to jump over row groups probabilistically. There are trade-offs in sorting it. We can probably come to that towards the end of the talk if there's still time. You're trading, the short of it is you're trading off between parallelism on the one hand and effective filtering on the other. I'll move on. We can ask me about this later. Performance tuning, it pays to understand your queries. You really want to look at the queries that are generated by your UI or BI tools or written by naive users. It's possible that the query is not optimal for Hive. What do I mean? Definitely use partition predicates. Everyone knows this. Relational operators and partition predicates. Everyone knows this. What about if you were to use a UDF in your partition predicate? If the UDF is a runtime UDF, you're inviting a full table scan because partition pruning happens during planning. So if you were to use something like Unix timestamp, you should instead prefer things like current date, current timestamp, which are now, with Hive 1.2, they are more compile time UDFs. They are evaluated once per query as opposed to once per row. Similarly, if you're going to be doing string operations, if you can get away with using like and in string, instead of using regexes, prefer those. Because regexes, while they're generic, they're also slower. I'd like to go over some of the performance enhancements that we at Yahoo have made in order to get there in terms of performance. And we start with index-based filtering that we just discussed. It's not just available in Hive now. We have added support in hcatalog. So you should be able to get this using pig and MapReduce as well. We have had to make some adjustments to the ORC split strategies, the way splits are generated. The erstwhile BI strategy used to generate one split per file. We changed that to one split per HDFS block to make things more parallel. Incidentally, that was checked into Apache Hive independently of our work as well. Secondly, the ETL split strategy in Hive, it's available today. It attempts to filter out ORC stripes at the client side, which means before your job begins. Now, it does this by launching 10 threads to go over the files on the client side. Now, this simply does not work at Yahoo scale because we have thousands of partitions, hundreds of thousands of files. Doing it on the client side does not work. As a proof of concept, we have a version of the ETL split strategy that launches a Hadoop job to generate the splits, which will then be used in the Thais job, which runs your query. How's that for meta? We can go over the nuts and bolts. Again, you can ask me after the talk. And third, we have made the ORC write path more memory efficient, especially for complex data types, by suppressing the dictionary streams, because that was a good way for us to run out of memory during write. Let's see. On the query side, joins. Who here has run into the need for skew joins in Hive? It is possible that this is peculiar to Yahoo's use case, but skew joins is when you're joining tables and a very large percentage of your records actually corresponds to the same join key, the value of your key. And because of that, it bogs down a single reducer. This is a solved problem in Pig. And now, so there is a version of skew join that's available in Hive already. That is a compile time mechanism, which is your table definition is expected to have not only the skewed columns, but the values with which they are skewed. You're supposed to know your data that intimately. It's a bit cumbersome. So Selena Zhang from Yahoo is somewhere here. She has a working implementation of runtime skew join for Hive. And it works very similarly to Pig, which is it runs a task to sample the data, to sample the input data, to discover the distribution of the keys, and then feed that back into your table scans so that the mappers can target the appropriate reduced sync. So that way, we have a version of this that the initial performance is quite promising. It'll be coming to a Jira near you very soon. I should also point out we've improved merge joins a little bit, particularly for wide tables. We've made that, we would frequently run out of memory, especially for wide tables, and we fixed that by making the row containers, which hold the results of your join. We've made those spillable to disk. There's some miscellaneous stuff here. If you use workflows using Uzi, and you discover partitions using hcatalog, we've made that path a whole lot faster. The hcat discovery partition discovery APIs have been made 10x-ish faster. The way we did that was by limiting the amount of thrift data that goes through. So you no longer need to list entire partition objects to figure out whether the data for yesterday is available to kick off a workflow. And finally, I'll talk about the fetch optimizer. We have optimized the fetch task optimizer some more. The fetch operator optimization is what allows you to do things like select star from this table, limit 10. So that returns without actually launching a Hadoop job. The problem is, if you attempt to run that on tables like ours with thousands of partitions and hundreds of thousands of files, you land up with, it takes forever to return because it needs to list all partitions. So what we've done is batch loaded the partitions so that we load just enough partitions to answer the query. So that makes things faster. And that brings me irrevocably to the Avro rant. Now, bear with me a moment. So Avro has seen a tremendous uptick in adoption at Yahoo now, particularly in cases where performance is not a factor. For example, intermediate stages of your pipeline, where most of your columns and nearly all of your rows are going to be read anyway. If you're going to be doing row scans, then columnar storage isn't really going to help. So in those cases, and in cases where the data set is under development, which means the column schema is still in flux. So in those two cases, Avro SERD is rather popular. And you can see why. Avro is self-describing in that the write schema for the file is stored inline in the file. It is flexible in that you can change a column from int to string to struct of int and string based on your whim. And third, it is generic because if you need to read it, all you need to provide is a generic read schema which mentions all three alternatives to the column schema, and you can read the data uniformly. People tend to get fanatical about their data format choices. Our advice to most of them, most of the Hive users at Yahoo is, if you're using Avro, for the sake of flexibility, by all means do, as long as your schema is still under development. But once you have actually hardened your schema and stabilized it, you really should be switching over to a more performant file format like ORC. Now, that again, for the most part, that advice kind of sticks. On rare occasions, you are surprised by replies such as this one. Mind you, this is exactly one user that suggested the following. There is no such thing as a mature schema. The only constant is change. Sort of Eastern philosophy there. We reserve the right to change our column schema several times a day. Now, several times a day sounds a bit much. It is not representative of the larger community of Hive users at Yahoo, but you do get a few of these on occasion. The problems that we had in production didn't have to do with Avro itself. It had to do with the glue code, the Avro SERDI that glues Avro support into Hive. And it stems from three things. A, for Avro to read the data file, you need to provide it the read schema. Typically, the read schema is written to HDFS in a small file. The Avro SERDI reads the file and then reads the data. Number two, the SERDI is exercised for read inside mappers. And three, it is not uncommon for ETL jobs at Yahoo to use 10,000, 20,000 mappers. So you put all this together, and when the production job runs, you have 20,000 mappers in a rush to read the read schema. The wrath of 20,000 mappers descends upon the three data nodes that are serving the blocks for this file, and they take out the nodes. And that's probably bad enough, but it gets worse because the data would then get replicated to other nodes, or you might have the owners of the data might increase replication factor so that other data nodes can serve this. The retries on the jobs or the failed tasks will take out those as well. So you have Avro SERDI sort of marching to the beat of its own drum, trampling on our HDFS willy-nilly. Annoying the Hadoop team, really. So we had to kind of sort of step in and stop that silliness as the kernel in Monty Python. Our solution in the end actually involved writing an optimizer that would prefetch the read schema before the job actually started and distributing it to the tasks. I can describe again later on after the talk maybe. Ask me about that for the nuts and bolts. But I think the quest for the ideal row scan data format is sort of ongoing. I'm not entirely sure that Avro SERDI in its current form is the best one to deploy, so we're going to be working a little bit there. I should also mention that SKU-join is undergoing hardening. We will be releasing that very shortly as well. And we will take a long, hard look at stat storage, which is a big challenge for data sets of our scale. With that, I think I'm mostly done. Right. Josh and I would like to acknowledge that this was a team effort. I should really call out Chris, Selena, Michael, Olga, Samir, and Ravi for their help. And with that, it'd be our honor to take questions. Thank you. Yes, sir. And I'll repeat it, yeah.
One question to you is, why do all really cool things like transactions, updates, authorized query executions are recommended only for OSC? Why they take a bound?
Okay, so I think the question was, why are the cooler features for Avro, for example, cooler features for Hive, for example, you mentioned vectorization, ACID and so on, why are those implemented for only ORC? Okay, that's a great question to the Hive community in general. I think I think support for vectorization it's a matter of who's going to write it, I guess. There is, I'm guessing, a very large community behind using Hive on orc, which is why the focus remains there. I'm not entirely sure why support can't be added to other file formats as well, but I think it makes a clear suggestion that ORC has first-class great support within Hive from features being added. It's not something that I could probably answer. If I were to add a new feature, what I would want to do is make it available for the data sets that my clusters are using. And so in this case, it would have to be ORC.
Okay, thank you. And next question is, what columnar format can you advise for a greenfield project? I mean, Avro, Parquet, or ORC?
Say again, please?
Which one of three formats with row-oriented storage can you advise for a greenfield project?
For a what project?
For a new project.
For a new project, okay. I don't have experience with, my experience is mostly with orc. I would highly recommend that you use orc. There have been, actually, you should probably go to Owen's talk at 5 o'clock today, because he's actually going to be doing a shootout from the sounds of it. If I were to back one horse, that would be orc, because we've had most experience with it. It was stable first when we were looking at it, 3 years ago maybe. So we are actually quite convinced at its performance. We're using it in pipelines everywhere. You've heard Josh's experience with it too.
So it's correct statement that Yahoo uses ORC for all the critical data in the clusters?
Correct.
Yes.
It's a recommended format for all data pipelines.
Okay, thank you.
Yes, sir. Sorry.
In your Hive table store, meta store, do you have a security placed on them, like Kerberos and all that stuff? You do?
May I take that?
We use Kerberos, yes.
Yeah, so you're asking, I think the question is about how security works in Metastore.
No, basically means that it's a secured cluster or not. So
yes, absolutely. Yeah. We've been running security since it was available. So, okay. So yes, it is HDFS-based security. That's what we run.
Okay, thank you.
And there's also a gentleman at that end too.
I think one over here as well.
Sorry. You talked about complex queries, but when you were talking, you know a definite pattern. You talked about a funnel, you wrote a UDF function, but when you talk about a data mart, you don't know from where the user is going to ask the question from, because there are 10 different dimensions on a fact table. I can say, hey, give me the fact rows based on segmentation, based on state, based on trading pattern, whatever. So how do you address those kind of situations? Because we did all the things. We did the ORC file format, partitioning, all the parameters you did. Now, I don't know where the user is going to ask the question from. How do you address this situation?
So what we do is we actually meet with the users extensively before they ramp one of these systems up. And what we do is we have them construct exactly what it is that they're trying to get out of the data mart. We don't actually have them define schema. Really, their whole purpose of building this is to answer some sort of questions. So give us a list of those questions. What is it that you are going to use this for? What could you see this being used for? Talk to your product teams, your sales teams, your marketing teams. Then once they know that, we actually say, these are the columns you should be projecting. This is probably how you should be doing it. And then as we work across multiple of these teams, we start seeing patterns. A common one was funnel analysis, which I called out. And as we see those patterns, then we go in and we build a generalized solution for them.
So in that situation, do you see this different from a relational database modeling? Because in relationships, I can indexes on that column and then I can do all that. But with respect to do this, I can partition, but then I have to go multiple layers of partitioning and indexing. How do I do that?
Now, when you say indexing, I'm not, this could be a longer discussion,
Yeah.
but if you're using index tables, one of the reasons we suggest that you use Orc is that Orc is fantastic at indexing within the file itself.
Yeah.
So, so those indexes are built for all columns. In addition, you can choose to create Bloom filters based on the columns that you'll need to do this at the right time. But you can build Bloom filters based on columns, 4 columns that you choose. So you'll need to use a combination of deep partitioning, rely on indexes sorted so that you can use index-based filtering, and then use Bloom filters. So I would recommend using all the, we can talk more.
Unfortunately, I think we're out of time at this point, so maybe you can take this offline if there's additional
Absolutely.
questions.
Absolutely.
Okay, thank you, everybody.
Thank you.